and we stop when these two index go across each other. Okay, that's the basic idea of this one. But either one, this one or that one, I mean, they are both called quicksort, depending on which textbook you are reading. The quicksort may be introduced slightly different, but the basic idea is to achieve this one at the end. Okay? So, well, now we finish the introduction of quicksort. So let's have some words about the complexity of this quicksort. Okay. To make the analysis simple, let's assume all input elements, all the elements that we want to sort are distinct. This way, it makes our discussion easier. Okay. So if there are some duplicate input elements, actually there are better partitioning algorithms out there, okay, that can make they can make the sorting algorithm the quicksort algorithm to run even faster, okay. But let's assume that all elements are different now, so that Tn indicate the worst case running time on an array of n elements. So let me ask you, what is the worst case?
N squared.
Huh?
N squared.
N squared, yes, why? And what situation will lead to n squared? The issue is that, okay, think about this. In the divide and conquer, if we are able to achieve two parts of roughly equal size, then it will be a perfect scenario, right? But in the worst scenario, if each time you only, one side is empty, the other side is all the elements are in the other side, then it's pretty bad, right? It means that you are not going to, how should I say, the divide and conquer doesn't give you any advantage here. So, so worst case is that, if your input is already sorted, either extending or descending, doesn't matter. Okay, and in that case, okay, your partition will always happen. Okay, the pivot will always be picked as a min or max element. Okay, so if that's the case, one side of the partition always to be empty. If that's the case, okay, your time complexity is going to be Tn equal to T0 plus Tn minus 1 plus T theta n, because this is the time you need for partitioning, right? And T0, well, one side is empty, right? T0 really you don't need to spend much time. Assume this is empty, that's fine. But the issue is you have n, this theta n plus Tn minus 1. So this is theta 1. Theta 1 is this one. Of course, this doesn't matter. So you have this one. But this one, okay, if you try to keep expanding it, basically it's like T of n equal to n plus n minus 1 plus n minus 2, blah, 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 plus 1. So eventually, it will give you n squared. So this is pretty bad, because it is arithmetic series. Okay? So, what do we do? Okay. So, well, because today I need to go to Zhongzheng Daxu, immediately now, after the class. So I will stop here. So next time, we'll start from here, okay? So, but I think I cover like the part that is necessary for the homework, right? The chapter 2 and 3, right? Okay, so yeah, so anyway, so remember to check out the homework and yeah, I will see you guys next week. Okay? Any question?